Okay, so this is the Module 5, Lesson 15, Concept Development. So if you haven't already done the fluency or the application, go back and do those videos now. If you have, let's go ahead and get started. So you will need pencil and paper because you need to be doing this along with me as I'm doing it. So go ahead and pause the video now and go get that. Alright, so let's get started. So we are going to be comparing 3/4 and 4/5 with unrelated units. So we're going to start by drawing two squares, and you're going to partition the left into fourths by drawing vertical lines. So I've gone ahead and done that for you now. So here's our first square on the left, and it is split into fourths by drawing vertical lines, so the lines that go up and down. So pause for a second until you have a drawing that matches mine. Okay? So next we're going to draw the next square, and we're going to partition the right square into fifths by drawing horizontal lines. So I've gone ahead and done it. So now make sure you go ahead and draw your square and split it up into 4/5 and shade it like I've done mine. Alright, so now I'm going to be looking at the fraction here. Do we have the same denominators or units? So if you look up here, it says we've got 3/4 and then we have 4/5. So our units on this one are fourths, and our units on this one are fifths. Oops. So is that the same? Units? No, it is not. So we need to go ahead and why is that happening? That is really frustrating. We need to go ahead and put them so that they have the same units. Well, let's see if I can do this now without it doing that. Okay, good. Alright, so let's go ahead and draw the 5 horizontal lines over our 4 vertical lines. So it would be like if you go 1, 2, 3, 4. So it should look something like that. Now I've gone ahead and done this and shown it to you using neater boxes and a different color so you can see it better. So go ahead and draw those lines until you get something that looks like my purple square here. Alright, now we're going to figure out what is our new unit for our four. So how many boxes do we have here now? So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our new unit is 20. Alright, so now what we're going to do is that we're going to do the same thing to the fifths. So, but instead of drawing the horizontal lines breaking up into fifths, we'll be drawing vertical lines breaking up into fourths. So here we go. So I'm going to draw, ooh, this is really bad. I apologize. Fourths. So we have 1, 2, 3 fourths. Alright, so again, I've done this so it's a little bit neater. So you should have a drawing that looks like the purple one down here at the bottom. So again, we're going to check, is this in, what are the units in this one? Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our units are still 20. Alright, so we now have the same denominator or the same units. So we have 20 over here, and then we have 20 over here. So now we need to figure out how many are actually shaded in. So you can either do 1, 2, 3, 4, 5 times 3, or you can count them up. I'm going to do 5 times 3 because I know that's 15. Well, if I look at this one, it's 1, 2, 3, 4 times 1, 2, 3, 4. So 4 times 4 equals 16. So now we're going to compare them. So is 16 20ths bigger or smaller than 15 20ths? It's bigger, right? So if I were to use my greater than, less than, or equal to sign, I could go ahead and do it like this, right? Because 16 20ths is bigger than 15 20ths. Now if I wanted to write this and put it back into our original unit, so we had 3/4 and we had 4 fifths. So now I can compare these, and ooh, what in the world? That's crazy. Okay, so now I can go ahead and compare these, say that 4 fifths is bigger than 3 fourths. And we've proven it by looking and making these boxes. Alright, so let's move on to the next problem. Alright, so we are going to compare improper fractions. So it says, use a number bond to express as the sum of a whole and a fraction. So we're going to go ahead and do that for both numbers. So we have 5 thirds and we have 7 fourths. Alright, so we need 2 number bonds here. So we want to break these up into our whole and our parts. So we have one whole, we have 3 thirds, and then we also have 2 thirds left over, because we know that 2 plus 3 will give us 5. So we have 1 whole right here, and then our parts has 2 thirds. Okay, so we're going to do the same thing here. So we have 7 out of 4, and so we at least have 1 whole, and so we have 4 fourths, and then in this one we have left over 3 fourths, because 3 plus 4 gives us 7. So this becomes 1 whole and 3 fourths. Okay, so when we go to compare these, we know that 1 whole is equal to 1 whole. So we don't even really need to look at this, because these are the same thing, right? So we can just go ahead and compare the fractions 2 thirds and 3 fourths, right? So let's go ahead and do that, and we're going to draw some area models to help. So we have our box here, and we have 2 thirds, so that's, I'm going to draw thirds here, and then we have 2 of them. I'm just going to shade them in like that. And then we have 3 fourths. So I'm going to try and make this one, oof, guys, I'm so sorry, roughly the same size. See, look at me, I'm trying to get ahead of myself. Alright, and then split this into fourths. So, like this. And it says we have 3 fourths, so I'm going to go ahead and shade in 1, 2, 3 out of 4. Alright, so which one looks bigger? 2 thirds or 3 fourths? Well, to me, 3 fourths looks bigger. So, let's see if we can find another way to just prove this. So, we have 2 thirds and we have 3 fourths. Alright, so how can I make 3 and 4 the same so that we can compare the numerators if the denominator is the same? So the easiest way to do it is just to multiply by the other number, by the other denominator, because you could list out the multiples and go 3, 6, 9, 12, 15, 18, 21, and so on and so forth, and then go 4, 8, 12, 16, 20, 24, but you'll find that oftentimes the least common or the lowest common denominator is actually the 2 numbers multiplied together. So in this case it is 12, because that's the least common multiple of both 3 and 4 that intersect, which would be 12. So I'm going to go ahead and write my new denominators out to the side here. So we have 12 and 12. And we multiplied 3 times 4. So what we do to one side, we must do to the other. So 2 times 4 will give us 8. And then we multiplied 4 by 3. So we have to, whatever we do to one side, we must do to the other. So 3 times 3 will give us 9. So which one is bigger? Well, 9/12 is, which means 3/4 is bigger, which is what we initially thought. So that's another way to confirm it. All right. Okay, so now we are going to compare with common units. And so we want to find out what is the common unit between 3/5 and 8/12. Well, when we look at this, we have our denominators, our two denominators, 5 and 12. So we need to figure out what are the multiples of the number of those two denominators, and what is the closest or lowest number that they have in common. So if we list the multiples of 5, we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. All right, and that's all the ones I have room for. And so now we can list the multiples of 12. All right, so we have 12, 24, 36, 48, then we have 60, then we have 72. Oh, you know what? I've already found one. So what we could do is we need to just circle the one that they have in common, and it's 60. So you can go through these and see that none of these overlap, because it has to end in if it's a multiple of 5, it has to end in a 0 or a 5. And so none of these end in a 0 or 5 except for 60. So that is the lowest common unit between them. So how many times do you have to multiply 12 to get to 60? Well, it was 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5. Oh, well, we could have, again, so you can list them out like this, but oftentimes, like I just said, the lowest common multiple between the two numbers is often if you just multiply them together. So that's kind of a little trick that you can do, but it might not always be the lowest common multiple. So it is good sometimes to list this out, especially if the question is asking you what is the lowest or the least common multiple between the two. So then it might be a trick and you might need to actually list them out. So always just pay attention to what the question is asking you. So we did list out and we found it was 60, and that's by multiplying each number by the other. So what I'm going to do here is we're going to find the full fraction. So we have 3/5 times 12, because we know that 5 times 12 will give us 60. And what you do to one side, you must do to the other. So 3 times 12 equals 36. And then we're going to do 8/12. So we have 8/12. And we're going to have to multiply each side by 5. Because, again, that will give us our new denominator, which is 60. So 12 times 5 equals 60. And then we have to do 8 times 5, because what you do to one side, you must do to the other. So 8 times 5 will give us 40. Alright, so now we can look at this. And we've got 3/5 and 8/12. And we've now changed these down here to be 36 out of 60 and 40 out of 60. Okay, so 3/5 and 8/12. Well, which one's bigger? 40 is bigger than 36, and we have my alligator facing this way, which means when we go here and we look at this, we say, well, which one is the larger fraction? 8/12 is actually the larger fraction, because when you change it, and you can compare it, when you change it to the same denominator, you can compare it equally. So, all right. And that's it. So you can go ahead and get started on your problem set. It looks very similar to the problems we've done. especially the first couple problems are very much like the first couple problems we did in the concept development. So if you need to, stop, rewind, and go through this again. All right. See you for lesson 17.